Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal Hazim Bezaizan. So I will introduce about introduction of our project. The material characterization is the process of analyzing and evaluating the properties and behavior of a material. First, the technique is SEM, is an imaging technology that uses a focused electron beam to create high resolution pictures of a sample surface. Next, we will use SRD. SRD is a popular method for determining the crystal structure of materials. It entails exposing the material to X-rays and analyzing the resultant diffraction pattern. The third technique is the FTIR. FTIR works by measuring the sample's absorption of infrared light. It detects particular chemical bonds such that allowing the identification of organic compound and their structures. We will do another technique which is EDS. EDS combined with SAM. EDS enable to analyze to discriminate samples by detecting the elemental composition of the polymer, mica substrates or coating utilized to produce the apparent color of the particle. Next, I will pass it to Azhari to continue the procedure.
Thank you, Akmal Hazim. Assalamualaikum and hi. My name is Muhammad Azhari bin Adnan. I would like to present about the standard procedure of this assignment. First of all, process flow charts are valuable tools that provide a visual representation of the step involved in a process. The flow chart has shown the flow on how this assignment was completed, starting with the division of group consisting of 5 members. Next is distribution of the samples. The samples given to us are sample 18 and 20, which are metal and non-metal respectively. Then does the analysis in the material lab. 3 material characterization methods were carried out, namely the X-ray diffraction XRD method. Second one is Fourier transition infrared FTIR method, and the third one is scanning electron microscopy SEM. All data from the study has been recorded and analyzed in the discussion section. Lastly is the documentation part. All the results must be recorded and discussed in the report. Now, I will explain what is SRD, FTIR and SEM. XRD is the technique used to examine a material crystal structure, phase composition and lattice characteristic by using X-ray interaction. For FTIR, it is the technique which involves examining a material infrared light transmission, absorption and reflection to learn more about its chemical makeup, functional group and molecular structure. As for SEM, it provides data on surface morphology, topography, and elemental composition of material as well as high-resolution imaging capabilities. Next, I will pass the floor to Hazi Azimi. Thank you.
Thank you to Azhari. Next, I will explain about the data analysis. SRD is used to identify the crystalline phase in a material. Scientists can determine the phase present in a substance by comparing the diffraction pattern acquired from an unknown sample with a database of known patterns. 2 unknown samples has been observed. For the sample 18, the data analysis shows peaks that relate to the sample. There is a variable line with the precise color and type of materials. And the line match a few peaks of our pattern, which are peak number 2, 3, 4 and 6. This enables us to verify that the sample substance contains carbon, diamond and iron. By comparing peak location and intensity to the reference pattern, it is possible to determine whether the detected phase exists in the sample. The higher peak in line intensity for sample 80 is peak number 2. And for the sample 20, the information display the location of the peak in the SRD pattern that represent the material's crystal plane. As observed, the sample corresponds to a total of 7 peaks. Diamond is a blue color, carbon and pink, and silicon green and purple. Layers of the ceramic has been observed in the content. As can be observed, the reference line corresponds to peak 4 and 7 as shown. We can verify the presence of the identified phase in the sample by comparing peak location and intensity to the reference pattern. A good match suggests that this sample contains the identified phase. For the second result, by using FTIR, Fourier transform infrared spectroscopy is a method that examines an object infrared radiation emission or absorption to reveal detail about its molecular structure and chemical bond. When infrared radiation strikes a sample, an interferometer divides into two rods, one traveling through the sample and the other serving is a reference. An infrared spectrum is created by Fourier transforming the resulting interferogram, which exposes detective peak associated with molecular vibration and shed light on the sample chemical composition. For the net result, I will pass to Fakro Ikmal.
To analyze the surface morphologies of the samples, scanning electron microscope is being used. Surface morphology is a subset of analytical imaging, which is an advanced form of high spatial resolution imaging that uses sophisticated microscope to produce images of product, samples, and objects that cannot be seen with the naked eye. Such images originate from the exposed surface of the sample or product. At 1K magnifications, secondary electron technique is used as the SE detector is placed at the side of the electron chamber at an angle in order to increase the efficiency of detecting secondary electron compared to 5K magnification that use UVD, where it can efficiently detect SE generated from the specimen when it is irradiated by an electron beam under a low vacuum and a bias voltage is applied to the detector front edge. The surface for sample 18 is rough, as sample preparation such as grinding and polishing is not being conducted. Hence, microstructure analysis for sample 18 cannot be done. For sample 20, the surface for sample is smooth, but there is appearance of crater with the size range from 80 micrometer to 120 micrometer. For the material composition analysis, by using EDX, I will pass to Farid Arashi.
For the next result, I will explain the result from energy dispersive X-ray spectroscopy, which is EDX. As we can see in figure in sample 18, the content of fluorine, manganese, and iron with the chemical composition corresponding to the phases can be observed. The high content of Fe particles in eutectic structure with active 0.5% of atomic weight percentage. While in sample 20, the presence of oxygen, silicon, potassium, calcium, and zinc in specific location of the backscattered image, indicating the phases. High concentration of O particles within the eutectic structure, accounting for 74.7% of the atomic weight.
So I will conclude here. The analysis revealed that sample 18 contains carbon, diamonds, and iron, while sample 20 consists of diamond, carbon, and silicon layers within a ceramic material. SEM examination showed that the sample 18 has a rough surface while sample 20 has a smooth surface with craters. And then the FTIR spectroscopy detect the presence of hydroxyl, which is OH, functional groups in sample 20, indicating compounds with hydrogen bonding interaction. So next, the technique EDS analyze identify the elemental composition with sample 18 having a high concentration of iron particles and sample 20 containing oxygen, silicon, potassium, calcium, and zinc. Next, I will propose two techniques that not owned in our lab that also can characterize the materials, which is FAM and DSC. FAM is a technique for seeing extremely small objects at the nanoscales. It scans the surface of a material with tiny tips and detects the force between the tip and the surface. As it travels, the tip develops a comprehensive 3D map of the surface, revealing details such as bump, hardness, and height changes. FAM can also detect stiffness, conductivity of electricity, and magnetic interaction. It is used to analyze microscopic structures and comprehend surface features at a very small scales in domains including material science, nanotechnology, and biology. Next technique is DSC. DSC is a technique that helps to comprehend how materials react to temperature changes. It monitors the flow of heat into and out of a sample when it is heated or cooled. We may learn about the sample's characteristics such as melting temperatures, phase transition, and chemical reaction by comparing its heat flow to that of reference materials. The DSC may be used to investigate the thermal behavior of materials in domains such as polymer, medicines, and food science. Thank you.